Okay, let's review how to add and subtract rational expressions that have the same denominator. So, adding and subtracting rational expressions that have the same denominator, for example, 2 divided by x plus 8 divided by x. Those are two rational expressions with the same denominator. It's like working with like terms. So what do you mean working with like terms? What is 2x plus 8x? Well, you know that 2x plus 8x is 10x, right? The same way, what is 2xy plus 8xy? Well, these two terms are like terms, so that is 10xy. In the same way, if I'm adding 2 divided by x plus 8 divided by x, that is 10 divided by x. Okay? So what is it that I do when I'm adding fractions that have the same denominator? I'm going to copy the denominator, okay? Copy the denominator. I'm going to add or subtract depending on what I am needing to do. I'm going to add or subtract the numerators. And the last thing I need to do is I'm going to reduce. Okay? So let's go and do an example. We don't need that many examples of this. This is a really easy operation. I'm going to work with page 435 of your textbook. So I have x divided by x squared minus 9 plus 3 divided by x squared minus 9. So I see that these two expressions have the same denominator. So I'm going to copy the denominator, right? And then I'm going to add the numerators, x plus 3. So here it goes, x plus 3. Now I need to look and see if I can reduce. Obviously, I can't do anything with the numerator, but the denominator can be factored. So I'm going to factor the denominator into x plus 3 times x minus 3. And I can see that the top and the bottom have a common factor, which is x plus 3. It can be cancelled. So at the top I get 1, at the bottom I get 1 divided by x minus 3. So I copy the denominator, I added the numerators, and I reduce. Okay? So this is a typical example on how to add two rational expressions that have the same denominator. Okay, so let's go with another example. And now I want to go to page number 439. I'm going to do problem number 8, but this is our second example. Okay, so I have 2x divided by x squared minus 4 minus 4 divided by x squared minus 4. Okay, so they have the same denominator. I'm going to copy the denominator, right? And I'm going to subtract the numerator. Okay, now I need to try to reduce. And now I want you to look at the numerator here. I can factor the 2, right? And I get 2 divided by x minus 2, or 2 times x minus 2. And then the denominator is a difference of perfect squares. Can be factored as x minus 2, x plus 2, right? And then I can simplify these two common factors, and the final answer is 2 divided by x plus 2. Okay? I want you to notice that these 2 and these 2 cannot be simplified. Okay? They cannot be simplified because this 2 is a term, and we don't simplify or cancel terms. We cancel factors, and we cancel common factors. Okay? So let's do another example. Okay? And in this case, I have, let's go with, this is a much bigger example. So we have t squared minus 3t plus 2 divided by t plus 1. We're working with page 435 of your textbook. minus 3t squared plus t minus 5 divided by t plus 1. Okay? So, good idea. Let's put this in parentheses, okay? Because there are expressions that have several terms. Okay, so copy the denominator since the denominator is the same, and then I'm going to take care of the numerators. Don't forget the parentheses, t squared minus 3t plus 2 minus parentheses 3t squared plus t minus 5. Remember that this negative sign is going to change, right? The signs of the terms inside in the parentheses, so I'm going to get t squared minus 3t plus 2 minus 3t squared. This sign changes, it's a minus t plus 5, and then I get a t plus 1. Okay, and now let's just combine line terms. I have t squared minus 3t squared is negative 2t squared, correct? And then I have negative 3t minus t. I have a negative 4t, and I have this 2 and this 5, and have a 7. And then in the denominator, I have a t plus 1. Okay, so I'm going to leave that expression as it is, since I'm not going to be able to factor that numerator, so I'm going to leave it just like this. Okay, one very last example. I have x divided by x squared minus 9 plus 2x minus 3 divided by x squared minus 9. Okay, the denominators are the same, right? Because the denominators are the same, I'm going to copy the denominator and I'm going to add the numerators. And I am sorry I'm missing here the 2. I just noticed that I missed the 2 from the book. Okay, so let me just write here x squared plus 2x minus 3. Okay, I need to reduce that, so I'm going to try to see if I can simplify the numerator and the denominator. Okay, let's look at the numerator, let's look at the denominator. The numerator is a trinomial. I have to find two numbers that multiply, give me negative 3, so they're going to have to be different signs, and I think plus 3 and negative 1 will do it. That gives me the 2. Okay? X squared minus 9, I have x plus 3, x minus 3. And this is a multiplication. So these are factors. Do I have common factors? I definitely do. I'm going to cancel these two common factors, and the final answer is x minus 1 divided by x minus 3. That is the final answer. So let's review the steps on how to add and subtract rational expressions with the same denominator. I'm going to copy the denominator. I'm going to add or subtract the numerators depending on the operation I'm working on. And I'm going to reduce, which means I'm going to try to simplify common factors. I may need to factor first. I need to find the common factors, and then I can simplify them and reduce.